Kia ora Year 13 and Year 12. This is the second linear programming video that I'm doing, and it's another Walker workbook example. This is on page 68, and it's a really common problem structure, so I want you to make sure that you have really mastered this before we move on to some of the harder skills. So I've just copied the task out, and I'm going to go through it, and we're going to use the framework that I introduced in the last video, which is this, VOC, G, COSY. So the hardest part in this task is the setup. It's working out the variables, then the objective function, and then the constraints. So I've had a couple of questions about how do we figure out what the variables are. Well, the variables are the things that you're going to choose, and there are going to be two of them. So let's read the task and look for some clues. So Claire is making bunches of flowers to go in buttonholes for the school formal, and she makes two different designs. So right there, that's probably going to be your two variables, design 1 and design 2. So let's keep reading. She has 20 fern leaves, 57 rosebuds, and 54 lavender sprigs. So those are not the variables, because that's the stuff she's got. We're not choosing a number of fern leaves, right? She's got 20 fern leaves. And then we're told that design A needs 1 fern leaf, 3 rosebuds, and 2 lavender sprigs. And design B needs different amounts of stuff. So our variables are going to be the number of design A flowers that she builds and the number of design B flowers that she builds. So that's the variables sorted out. So let's see how I wrote this up. So I actually cheated here and I grabbed my worked solution so I don't have to write it all out again. So the variables here are going to be X and Y, and I've written a very clear statement like this. So let X be, and then the number of design A, and then let Y be the number of design B. Of course you can do it the other way around. Everything will just be backwards in the end. Right, let's go back to the words. The next thing we do is we look for the objective function. So what does Claire have to try to maximize? Now she's trying to make money, so she's going to probably be wanting to maximize profit. Okay, so how many of each design should she make in order to maximize her profit? So P is equal to what? Well, it's how many she sells of design A and what she charges for them. And she charges $5 for design A, and she charges $3 for design B. So that's my objective function. And we're asked to figure out what is X and what is Y. So that's just written up nicely over here. So that's VO. Now the next thing we have to do is to figure out the constraints. So this is the hard part usually. And in here, what we have to do is to think about what are our limitations. Well, she's only got 20 fern leaves. She's only got 57 rosebuds, and she's only got 54 lavender sprigs, and she's going to use them up. So, the first constraint that we're going to write is about fern leaves. The second one is about rosebuds, and the third one is about lavender sprigs. So it's easiest to start by saying, well, what is it going to be? Is it going to be an at least or at most? We know that she's got 20 fern leaves, so whatever she does, she has to use at most 20 of those. So it's going to be a less than or equal to 20. How many will she use? Well, for every one of design A, she needs 1 fern leaf. So if she makes 5 design A's, she needs 5 fern leaves. That means that we're going to have X, and then the same thing for design B, right? So for every design B, she needs 1 fern leaf. So we're going to have X plus Y is less than or equal to 20. Let's look at the rosebuds constraint. She has 57 of them. So we're going to have is less than or equal to 57. But this time she uses up 3 rosebuds on design A and 2 on design B. So we'll have 3X plus 2Y. And we do the same thing for the lavender sprigs one. 54 lavender sprigs. So that's the biggest number she could possibly use. And she uses 2 of them on design A and 3 of them on design B. And that's all we have in this problem for our for our constraints. There's nothing else. This bit here we've already used. That goes into our profit function. So let's see, what have I done now? I've done the variables, I've done the objective function, and now I've done the constraints. So this is, as I said, a really, really common setup. It is really good if you can clearly label what you're doing as you're working, it'll make it easier when we get to more complicated problems. The next thing we have to do is G. We have to go to Desmos and we have to graph these constraints. And remember from the first video that what I need to do to make the colours all work out and get a nice clear graph is to reverse all of them. Okay, and the other two things that I have to say so that I get a good region is I have to say that my number of design A must be 0 or bigger, and the number of design B must be 0 or bigger. So I've done the final version of this, but I want to show you how it looks as I'm putting it into Desmos. So let's hop over to Desmos. Just get rid of that Education Perfect window. And I'll just get rid of all these because I've only used up 5 minutes. So we've got a bit of time on this video. The first thing that I'm going to put in is what we call the non-negativity constraints. So x has to be a positive number, but remember, I have to reverse that. Now, why do I need that? Well, you can see on the graph, if I don't have that, my white area is just going to go on forever into the negative numbers. So it's worth putting that in. I've watched people in internals forget about that one and wonder why they're not getting an edge to their feasible region. So don't forget about that. The next one is going to be the fern leaves constraint. So I type in x plus y. That has to be less than or equal to 20, but I reverse the sign when I'm doing it. Okay, and you can see that that's popping in my first real constraint. So then 3x plus 2y is greater than or equal to 57. And lastly, I get 2x plus 3y is greater than or equal to 54. Okay, so that white area is my feasible region. So we've done G at this point. And what we're going to work out now is which point in that feasible region gives me the biggest profit. So I'm going to show you why that's going to be at one of the corners. But first I want to show you how easy it is to get these vertice numbers up. All you have to do is with your mouse or with your finger, you just tap where you want. Yeah, I've just said how easy that is. Now I can't get that point to come up. Right, that's at 19. There we go. Okay, so that gives me the coordinates that I need to evaluate. But I want to go back now and show you the next little step about what this thing about the corners is all about. So let's look at what we're trying to do. We've got a profit function, right? And the profit function is this. It's 5x plus 3y. This profit number is going to change depending on what they do. And I'm going to think about this now as I'm going to rearrange the equation first and show you what's happening. So 3y is equal to negative 5x plus p. This is showing me the trade-off between x and y with the profits. Okay, so in here we want our line to be as far out as it can be, because that's going to give me the highest profit. Now this is going to make more sense, I promise, when I go back into Desmos. Right, so I've rewritten my profit function now, and we're going to see what happens. Now you don't have to do this in the internal, because you do this step by hand using a table of values. But I think it's really good to understand what's actually happening with it. So if we go into Desmos, I'm going to put in a profit function. And I don't know if that window is going to, I'm just going to try and move that window. Yeah, that's better. So you should be able to see now that I'm typing in this rewritten profit function. So y is equal to negative 5/3 of x plus p divided by 3. Now p is the amount of profit. And it's asking me if I want to add a slider. And what we're going to see is what happens as the profit gets bigger. So we're going to make p is between 0 and I'll make it between 200, and we'll do steps of 1. So you can see on the screen that a new line has come up, and it's the red line. And as I move the slider, you can see the profit changing. So what we're trying to do is figure out which point in that feasible region is going to give me the biggest profit number. You can see that where I've stopped it here gives me a profit of 34. So any combination along here will make $34 of profit. But you can see that that's not going to be what I do, because I can do better than that. I can get that red line going further out. So what I'm looking for is the best possible combination. In other words, the one that's going to give me the highest value of P. So hopefully you'll start to see why that's going to happen at a corner. So here, that point there is going to give me a profit of 54. Now you're going to work this out in a table, but you can also see it with a slider. And you can see from looking that now I'm getting even bigger profits. So I'm up to 65, 60, 70, 71. And there we are, I'm hitting another of those coordinates in my feasible region. So that one's going to give me 72. Right? But if we keep on going, we're going to see that the best profit there, at this corner point here, looks like I'm going to get about $94. But if I go even further to this one here, the 19 one, I'm going to make $95. So as I said, you don't have to be able to do this slider thing, but I think it helps you understand what's happening. So now we're going to go back to doing our VocG cozy without doing this weird slider thing in Desmos. So let's see where we got to. Well, we've done our graph, right? And our graph looks like this. So this is just copied over from Desmos, and you can see those vertices are all here, right? So these corner points are the ones that we now have to go and investigate. So we've done variables, objective function, constraints, we've done our graph, and now we go back and we get those coordinates and we put them into the objective function. In other words, we're going to see how much profit will I make with these combinations. And then I state which one is best and I interpret in context. So this is going to link up with what we saw with the weird slider thing, right? These are the coordinates that I have to check. And I substitute those XY values into the profit function. And you can see exactly what we saw on the slider thing, right? $54 when we had just 18 of the second design. $72 of profit here, 94 of profit here, and 95 of profit here. Now this makes complete sense because we had no costs here. We were just given the ferns, the rosebuds, and the lavender sprigs. And my profit function was 5x plus 3y. So since she can sell the first design for $5 and the second for only $3, she would be pretty crazy not to just make as many of those as possible. Okay, so we've found our best combination. It's $90. And let's just go back to this lovely slider thing. And now I'm going to show it to you again, and it might start to click, right? So this line, y equals negative 5x plus p over 3, the red line, is my objective function. But I've rearranged it to make y the subject. Okay, so as we change combinations of x and y, and we move through the feasible region, the profit's going to change. We want to find the highest profit possible. And so as that line moves out, that represents combinations of the two designs that give me a constant level of the profit. For example, here, I've stopped the slider on p equals 37. Right, so anywhere along that red line, any of those combinations will give me $37 worth of profit. Okay, but I can do better than that. So here's our first point. That's our $54 that we got in our table. There's my second point, 72. And you can see my $95 is happening on the x-axis at that very last point. Okay, so we've basically finished the task. But we were also asked what she will have left over. So things that I need to say now is I need to say the best combination for her to make is 19 of design A and none of design B. Lastly, we have to figure out what's going to be left. And, oh, where did it go? Okay, so she's going to make 19 of design A. She'll use up 19 fern leaves, 3 times 19, 57 rosebuds, and 2 times 19, 38 lavender sprigs. So she's going to have 1 fern leaf and 16 lavender sprigs left over, which is not going to be enough to do any more designs. All right, thanks for watching, and let me know if that made sense. And do have a play around in Desmos with doing the slider thing. I'm happy to explain how to set that up for you on a Zoom or something like that.